And now I'd like to introduce Daniel Mendoza, a postdoctoral fellow with pulmonary medicine and atmospheric science at the University of Utah, who's going to talk about other uses for these mobile measurements.
Good morning. I'd like to thank the organizers and Carrie for the great introduction. I'd like to talk about a little bit of what we're actually doing with some of the TRACS data, particularly with relation to health studies. So back in the motivation for this was back on December 20th. I don't know if any of you were around or paying attention to outside, but we had this pretty interesting dust event. So then I wanted to take a look at what is the spatial granularity that we can really capture this dust event. So I started looking at that first, and that's what my abstract is if you take a look at your program. But then we really had a little bit more time. I had a little bit of energy, and then I decided to take a look at 3 years worth of data. What happens in terms of the schools? What are children being exposed to? So this is sort of the motivation behind that. Now, as an overview, we already know that we have air quality differences across the Salt Lake Valley. And one of the topics that I like to talk about often is the socioeconomic exposure disparities. We do have this great observation network. I'll talk about it a little bit more, even though Logan's done a great job introducing it. And as I said, originally the main purpose of this was to really look at the dust event. I was actually caught outside in it, and look at what the chronic exposure is across the Salt Lake School District. And then to sort of end on a high note, look at the health and metropolitan planning projects in the future. So this all really started with looking at emissions. So this is called the HESIA project, and it looks at an emission inventory for multiple pollutants. Here I'm just highlighting two of them, nitrogen oxides and PM2.5 at a 200 by 200 meter resolution. It's an hourly inventory starting from 2012 all the way to 2017, and this is going to be an ongoing project. Part of the reason why I like to show this slide first or very early in my presentations is because whenever someone talks about pollution, it kind of grates me a little bit because we really want to talk about the different kinds of pollutants. We want to really look at this at a multi-pollutant approach, and I'm glad that Logan went before me because he showed how different, what different readings we have across the valley for different pollutants. So we can see nitrogen oxides are mainly associated with on-road sources. So we can see obviously in the downtown area and the large highways and also the mine. PM2.5 is mainly associated with large industrial point sources. So there's where we see the hot spots. Now, one slide that I always like to show is really looking at the socioeconomic attributes versus the 2014 emissions. Now, again, these are just the large point sources, concentrated sources, so we're not looking at area sources such as residential commercial buildings or the on-road sector, but these are just the large concentrated sources. And I like to put up these two pollutants, PM2.5 and VOCs, volatile organic compounds, just because there really are summer and our wintertime issues, the PM2.5 and the VOCs as ozone precursors. And the main point of this is that the majority of large emitters are located in low-income areas with a high percentage of minority populations, some vulnerable populations. So that's sort of the basis, because this is really what drives the majority of our pollution. Now, this is not directly affecting the dust event, but it does affect the chronic exposure. Now, I always like to show this slide because we look at species transport. This is what we really care about. The emissions, we get a good idea of their inventories, but we really want to know how they get transported and what are we actually really breathing, what is the actual exposure. Now, if we look at what the original observation network here is, and this is all based on the DAQ sensors, the first sensor, as we all know, was Hawthorne, and then a few years ago, 2 more sensors were added, and Harriman and in Rose Park, this for PM2.5. But if we start looking at this, for example, during those 2 inversion periods that are highlighted, there are large differences, almost a factor of 2 on the first event between the Hawthorne and the Harriman site. And then there's a little bit of also disparity on the February event as well. So we know that 1 sensor or even 3 sensors are not quite capturing the spatial distribution of pollutants. This PM2.5, ozone, the same thing. There are 2 sensors, Hawthorne and Harriman. We can see that at least consistently Harriman is always reading a little bit higher than Hawthorne. Now, what can we do? And the tracks project, as Logan mentioned earlier, was started in December 2014 because it is quite the ideal route. If we were to design a way to really measure a cross-section area of the county, the red line and the green line are really good for that. So that's a very important part of our observation network. Another really great asset is the helicopter. That's the KSL News chopper, and whenever the pilot flies, which is about 4 times a week, flips the switch, and we get now a 3-dimensional transect. So with all this data, we actually are the best observed city in the best observed area in the whole world, which is really great. It's a great asset. And now those black dots, in case you're wondering, those are part of the Meso-West meteorological observation site. So it can really tell us a lot about the wind direction, where pollutant flow would be. So we really have a very dense observation network. So let's use it. Now, December 20th, we actually got hit with 2 dust storms. And if you can, I don't know if we've got a laser pointer. Anyway, right in the middle, this green dot right there, that's part of the Salt Lake. And then we have Utah Lake just down south. So really you can see how obscure this is. We can't really quite see some of the features. Oh, great. Aha. So we can really see how obscure everything is due to this dust event. We had 2 similar dust events in terms of just their opacity, and these were really just 2 weeks apart from each other. So as I mentioned, I was actually out there, and I will show that an animation in a second, but these dust observations, you can really see how we're actually reaching down here. This purple air quality, which is way worse than the red air quality. And if I recall correctly, some of the instruments were actually saturated, reading over 700 at the PM10 scale. So it was quite catastrophic in terms of air quality. Luckily, it lasted a very short period of time. However, if you look at the time, it was really around close to 10 to 11 in the morning, which is when kids were out playing. Now, whenever we do any air quality studies, we look at, for example, patient addresses. We look at their home addresses. But I always like to tell people, I don't know of anyone who actually just sits on their front porch all day. So really getting that kind of air exposure is good to get sort of a sense of how polluted the neighborhood is, but that doesn't really correlate directly to what people are being exposed to. However, kids, they do go out to play. Now, there are 2 factors here. One is that kids ventilate faster than adults proportionally based on their body mass, and also because they're out on recess, they're probably burning off some energy running around, so they're actually doing some heavier breathing, which means that they're being more exposed to poor air quality. So this is this animation, and you can see a timestamp there. We're starting at 9 a.m., and it was actually taken from the WBB building, which is the Atmospheric Sciences building at the U. You can kind of see the dust start coming in, and then it's going to get worse. I was actually just out there. It was pretty ironic because I was actually going to discuss some air quality issues with the city council when the dust storm hit me right around this time, 10:45, as I was walking to the building. You can see how dreary it was out there. So I was thinking, well, let's take a look at what happens in terms of the schools. What were kids exposed to at that point? And so this is a map of the Salt Lake School District. And what we have right here, so this is West High School, and this is what I kind of decided arbitrarily and with some knowledge of the geography. This is sort of my east-west divide. So from here to here is we consider the west side. From here to here, we consider the east side. So again, if you really look at where the stars are located, it's really more of a 10-kilometer by 7-kilometer spatial area. Now, it's not a large area, but you will be able to see that we do have significant differences spatially. So now if we were to look at the dust event here at an hourly resolution, which is pretty good indication of what's going on in terms of the air quality. Again, as I mentioned, we have West High School, sort of the midpoint. The black line is what the DAQ sensors at Hawthorne read. And normally, if you're not familiar with recess guidance, normally what schools are supposed to do is they're supposed to take a look at the air quality. Most of them take a look at the air quality at 8 a.m. and then just use that as to whether kids should go out and play or not. Just as a reference, that orange line there, about 35, Anything below that, kids should be allowed to go out and play. Between the orange and the red, sensitive children or children that are sick should not be going out to play, but everyone else should. And then above the red line, no one should be going out to play. That's the current recess guidance. Now, 1 hour resolution, that's great, but as Logan mentioned, we're reading this on a second-by-second scale, so let's go a little bit better. And here's what happens when we average it out at 5-minute resolution. Now you can really see the large disparities across the school district. And again, this is a dust event. This only happens about 5 to 6 times a year, so we shouldn't be expecting this very much, which is what led me to look at the chronic exposure. Now, what's interesting here is that whenever we're looking at an air quality sensor, sometimes the data is a little bit delayed, whereas with the tracks, our maximum delay is about 4 to 5 minutes. So we can really see what the air quality is almost instantly. And if we were to look, for example, at the 10 a.m. hour, we can see how there were some underestimations, and that's mainly because the dust plume it just sort of snakes around a little bit, and so it's very hard to really capture what's going on. But again, with our instrumentation, so this is not just the tracks, it's also incorporating the DAQ sensors and our University of Utah sensors, so we can get a really clear picture of what's going on in terms of the schools. So now let's take a look at a more chronic exposure. So let's just take a look at 1 month, this is December 2016, and we can really see how an inversion is building up. Luckily, there are no kids at school then, because most schools end around the 20th or 21st, so they weren't around to see that New Year's inversion. If we take a look at now, let's look at the hourly average. And again, the black line is still the Hawthorne reference. We can see that there is quite a large gap or quite a large span in terms of the air quality exposure. The next pollutant that I really want to talk about is ozone. Now, even though ozone is really mostly a summertime problem, it is a problem for athletes, for any kind of varsity teams or any teams that practice during the summer, particularly because most of these practices happen during the middle of the day, and we can see that's where an ozone peaks. And so this is again our the same kind of scale. We look at the schools. West High School is again the midpoint, so the more blue, the more east, and then the more red, the more west the schools. And we can see that here the pattern has flipped a little bit, where the easternmost schools are affected by higher levels of ozone, whereas before the westernmost schools were affected by higher amounts of PM 2.5 exposure. So what I wanted to do was, let's look at the impact of having this mobile platform. So looking at this June 2015, again, I'm picking out summer months. So this is using all of our data sources combined, which means DAQ sensors, University of Utah stationary sensors, and the tracks. Now, if we remove the tracks, we can really see that we're starting to lose some of that spread. We are starting to lose some of that spatial granularity. And if we remove all of the University of Utah sensors, so here we're using the DAQ sensors, the 3 sensors, the 2 sensors, Hawthorne and Harriman, we can really see that we are definitely losing a large amount of the spatial variability. And if we remove the DAQ sensors, we sometimes underestimate, particularly during the peak hours, because the black line is still what Hawthorne reads, which is what most people are used to looking at. So one of the assets that we have in terms of the tracks is we can really start looking at some predictability in terms of what's going to happen in terms of inversions. What's the air quality going to be in the next few days? And this is that inversion episode that I mentioned at the end of 2016. We can see how on December 28th, which is when we're starting to get the inversion, that's sort of the lid closes, and we start to accumulate pollutants, and then we progress to essentially the entire valley is a redder day on December 31st. Why this is important is because knowing the evolution of an inversion, we can actually start to look at what areas of the city or areas of the county are going to start getting higher levels of pollutants. So our vulnerable populations, for example, COPD patients or cystic fibrosis patients, they will be more affected, and there's nothing worse than having a room full of these vulnerable patients needing to see a doctor and a facility potentially being understaffed. So what we're doing is trying to work with some of these predictive models to see whether we can start warning some physicians that they may be having some influx of patients. Another aspect that we want to look at are the emerging diseases. Utah is part of the suicide belt, And the governor recently put together a task force to look at teen suicides. And it really shows that there's significant interest in what we call emerging diseases. We do have established diseases such as cardiovascular, pulmonary, and cancer that are associated with poor air quality, but there are other diseases that have been associated with it. There are multiple reasons as to why we think this may be a factor. Some are direct mechanisms where it's actually deposition, direct chemical reactions. There are peripheral mechanisms where other systems in the body are affected, and that leads to depression, potentially increased suicides. A study back in 2015 showed a 20% increased risk in completed suicides, and this is a study done here in Utah. So this is a very local information. We're now looking at improving the spatial resolution of the exposure methods. Now, to end on a happy note, we are looking at many different ways of reducing emissions and trying to build towards a more sustainable future. We have this project called SimCity 2040, where we're looking at how we're going to more sustainably develop using the Wasatch Front Regional Council's development scenarios, and we're looking at things such as the meteorology. If we're going to be warmer, we're probably going to need less energy for heating, but more for cooling in the summer. And also we're including mitigation strategies. So for example, we always talk about electric vehicles, how great that is, but they also need the electricity, just as sort of as a spoiler, because the manuscript's going to be coming out probably in the next few months. If we have 50% of our vehicle fleet becomes electric, then we're going to be needing another Gatsby to power those. So we do have some community events. We've done them in the Glendale area. We're really working with the more socioeconomically challenged communities, because we think that they need much more incentives, a little bit more help in terms of there's many language barriers, cultural barriers, and that's part of some of the work that we're doing. And I'd like to end with a list of our collaborators and contributors. It used to be in the front page, but it would take up the entire page. And I'd also like to invite you to visit one of our collaborators, Daniel Babel. She's got a poster. And thank you, and I'll be happy to take any questions.